Today I'm going to show you how to do a simple parallax effect in Unity in 2D. And this uses an orthographic camera, so this is not in perspective mode. And it just uses a simple script to move the different layers. And all we do here is we have 3 different layers. So we have the background, which is the mountain. We have the middle ground, which are the clouds. And we have the foreground, which is the little hills. And they all move relative to the camera at different speeds. So the further away something is, it'll move slower. And the closer it is, it'll move faster, similar to real life. So when you're in a car, for example, you see the items nearer to you go faster because you are closer to them relatively. And then things farther away, such as the moon, move slower and they stay in your line of sight faster. If you are looking to use your own assets or incorporate other assets into your game, I definitely recommend checking out the Unity Asset Store. This video was graciously sponsored by Unity to promote Unity's awesome spring sale. If you haven't checked it out already, I would definitely recommend doing so. From April 11th to April 29th, there are over 500 of the best-selling assets on sale or 50% off. A lot of these assets can help you improve the development workflow of your game, improve the look of your game, and help you implement new features in an easy and productive way. There will also be something called the Lightning Deals, which is an awesome opportunity to grab over 160 assets at 80% off. So these assets will open up at certain times and be on sale starting at 80% off, while quantities last. As people buy the asset, the amount in discount will decrease, so it will go from 80% to 70% all the way down to 50% until the remainder of the sales. And if you're a first-time customer of the asset store and you're not sure whether to buy, you can use this code WELCOME2022 at checkout to get an extra 25% off your order. So check out the spring sale before it ends and nab yourself some awesome assets. So let's get started on the video. Alright, so I have Unity opened here and I have this tall layout just because I like it. And all I do is move the game view downwards so I can just get a better view of the scene. So first we need to import some images. So let's make a new folder. Right click, create folder. And we can just call these sprites. So these will be our sprites that we use for our different layers. And ууKenney has some awesome free assets that you can use for this that loop automatically. So we're going to make it loop infinitely, which is another awesome feature that we can implement really easily with 2 or 3 lines of code. So you can just download this and you can become their patron or follow them on Twitter or donate. Then you can extract the folder. And then when you open it up, it has some different folders here. In the samples, you can see how it would look with some sample scenes if you wanted to have that set up. There's a sprite sheet if you wanted to import all of these items, or we're gonna just do it one by one. So we click on the PNG and then you can choose whichever ones you want to import. You can import all of them if you want or not. So these are the ones with colors. If you don't want any colors, which we won't be using any, we can go into the flat folder here and then we can find some looping images that we can use, such as this pointy mountain. So I'm going to select that. I'm also going to select one of these hills. So I'm going to click Control and then click the hill. And then I'm also going to select a cloud. So I'm going to keep pressing down Control, click it, and then I'm going to drag those 3 into Unity. Also, if my voice seems a little off, it's because I was sick recently and it's still recuperating. But once these images have been imported, we can click the first one, press Shift, click the last one. And then in the import settings, we want to change the texture type to Sprite, 2D and UI. So we can use it as a sprite on our scene. And then it gives an error here of the compression format because it's not a multiple of 4, the height and width. So you can change this if you want. I'm just going to leave it as it is. So the first thing we want to do is add one of these layers to our scene. So you can actually just kind of drag it in. So we want this to be in 2D mode. So for our main camera, make sure the perspective is in orthographic. You can do this with perspective mode. With perspective mode, the depth of the item will matter. So if you change the Z axis here, you'll see that when you go farther away, it'll appear farther away. However, if you make the main camera orthographic, that won't matter because it's in 2D mode and there's no perspective as you see here on the scene. I'm just going to reset that Z value back to 0 here. And then in the scene view, you can click 2D mode so we can get a better view of this, how it will look in 2D. So let's position our image to be wherever we want in the scene. So I'm just going to put it near the bottom. And I'm also going to change in the game view here, the free aspect to 16:9, just so we can see in the camera how it would look accurately on our monitors, which are usually 16:9 resolution. So what we want to do is that we want to have each of these layers take up around 3 screens worth of length. So for these hills, I'm just going to extend the X until we reach around the camera screen here. And then I'm going to change the Y accordingly so it scales properly. Now, if you're doing a layers manually in Photoshop, you can adjust for this. So make sure that you're in the right resolution and that your texture loops correctly. So once we have one of these, we can duplicate it. So click the hills and press Ctrl D twice. Then we can click one of them, press W, and then move it. Now to connect this piece to this piece, we can press V and this square will pop up. And what you can do is that this kind of snaps the image in place, which is really neat. You can see that it automatically snaps it for us, but there is a bit of a gap here. So to make that gap less noticeable, you can go in the sprite settings of your image, and then you can go to Sprite Editor, which if you don't have it downloaded, because I accidentally selected a 3D project, you need to download from the package manager. So you can just go to Window, Package Manager. Up here, you go to Unity Registry, and we can just import this 2D sprite package, install it. And once it's been installed, you can now go to the sprite editor here, and you'll see that for some reason, these are the bounds of this sprite, which you can see by this little green square here. It doesn't go all the way to the actual image. For some reason, it adds an extra pixel. So you can just adjust this and drag this line right there where the boundary of the image is. And you can also do this for the other side. I'm navigating this by pressing down on the mouse wheel. So right here on this square, you can just click it and drag it to the boundary of the image. And then you can click apply on the top right. And let's just do that with all of the images just to get it over with. So if we go back to the scene, you'll see that it still appears there. So if you want, you can change it in the sprite editor again, or this time I'm just gonna actually move the hill a little to the side so it matches a little better. And you can adjust these values in the inspector as you see fit. So -18.13. And then the other side, we can just do the same process. Pressing V, attach it to here, and then we can move it a little sideways here. All right, so we have these hills set up, and I'll explain why we need 3 screens of these in a second. But let's start writing our script. So let's make a new folder. Right-click, create folder. You can call it scripts. Put _scripts so that it can always appear at the front of the assets folder, which is better if you have a bunch of folders later on. Then you can right click and create a C# script, and we can call this Parallax Effect or whatever you want to call it. You could double click it to open it up. I'm just going to remove these 2 functions and add them in later, and also remove the 2 using statements so we can start from scratch. So what we want to do is that we want to move each of these layers with respect to the camera. So first we need a reference to our camera, specifically the camera transform. So we can do private transform, camera transform. Then either in the start or awake, you can do camera transform equals camera.main.transform, and make sure that your camera is tagged as the main camera for this to work, or you can get a reference to it directly if you wanted to. And then what we're going to do is in the update function, which runs on every frame, we're going to move this layer accordingly. And so this script will be attached to our sprite. So side note, you can do require component type of sprite render. So that means that this script will only be able to be attached to game objects that have a sprite render attached to it. And you'll see why we need a sprite render in a minute. But basically, we want to move this in relation to the camera. So we have the camera transform. Let's specify a speed that we want this to move at. So serialize field so it can appear in the inspector. Then you can do private float parallax speed. You can set a default value if you want. And then in the update function, what we can do is that we're going to be primarily moving horizontally. So let's do parallax horizontally first. So we can do camera transform dot position dot x. So we're going to keep in track the current position of the camera, the x, and then we're going to times in our parallax speed so that this game object can move in relation to our camera position times a specific speed. And let's set this to some variable. So float, and we can call this relative distance, relative dist. Now we can set the transform.position of this game object and just create a new vector 3. And you'll see that we can't actually plug this in directly. We're missing a component, but let's try to plug it in directly to see what happens. So we have relative dist, and we want to keep the same transform position that we currently have on the y, transform position.y and transform to position.z. So let's attach this to our game object. And before we do that, actually, since we have these 2 hills next to the main one, these 2 hills will always be moving with our main hill. So we can actually make these children of the middle one, so that now when we move the middle one, the sides one will move. And this parent-child relationship will actually help us when we create the looping for the parallax effect. So on the hills, we can add in our parallax effect script by clicking add component. And then we can just set a speed. Let's just put 0.5 to see. So when we click play, you'll see that the hills actually move position. And that's because we're setting the X position to the camera position times the speed. And we're not taking into account the initial position that the hills are. So when you start the scene, the hills move because they're getting set to the current transform position of the camera times some speed. So it's an easy fix here. All we have to do is take into account our current primary position, which you can do with a private float start position X. And then in the start function, you can do start position X equals transform.position.x. And all you do is in this line where we set the transform position of this game object, all you have to do is add in the start position to the speed. Kind of reminds me of mx plus b, the slope formula. This is the starting. This is kind of the speed that we're moving at, the slope. And so if we start the scene, you'll see that now the hills won't move as expected. You see that when we move the camera, the hills are actually moving with the camera, but at a slower speed than the camera, which is one of the key ingredients that we need for the parallax effect. So you'll see that now the hills end. So what we want to do is we want to have the hills loop over and over again. So how do we make the hills loop over again? I have this little diagram here. So let's say we have these 3 screens with our hills or mountains, whatever these are. So let's say this is our starting point. So this is like 0, 0. So basically, once we're moving in this direction, let's say we reach the middle of this screen or the middle of where these hills are, you'll find that if the camera keeps moving forwards, suddenly the hills will get cut off because there's no more hills. So what we want to do is we kind of want to shift the screens over so that when the camera keeps moving, this will look like it's looping infinitely. So that would look like if we are on the 3rd screen in the center, it's about to cut off. So right before it cuts off, we can shift the entire screen. Having a little trouble drawing this, but we can shift the entire screen over 2 times. So now we're here, and when the camera continues moving, the hills will appear to be looping, and this will be instantaneous, so you won't even notice when this happens. And vice versa, if we're over here and we're moving that way, then we'll just shift this texture image 2 screens over so that it will loop on the other direction. So that's the gist of it, and it's pretty easy to implement. So to do that, we have to know the size of the current sprite. So we can do that by setting a variable private float sprite size in the X. Then down here, we can do sprite size X equals get component sprite render dot bounds dot size dot X. So this gives you the bounds of the render of the sprite render, then you get the size and you just get the X of that. So this will give you the length of our sprite, which if you remember, this is just the length of one of the screens because we're only attaching this to the main hill here. So we're only going to be attaching the parallax effect to the main hill, and then the other 2 hills will be following accordingly. So we get the sprite size, and now we just want to check where the camera is in relation to our hills or our layer. So here we can do loop parallax effect. So to get the correct camera position in relation to our layer, all we have to do is do float relative camera distance equals camera transform.position.x times, and I'm going to put this in parentheses, 1 minus parallax speed. So this is what we did to get the relative speed of the layer to the camera, but now we're doing it so that we get the relative camera speed in relation to the layer. So this will help us check where our camera is. So then we can do an if statement. So if our relative camera distance is greater than our starting position, so remember the starting position is the middle, 0, 0, plus the length, plus the size of the sprite. So this is the starting position right here, and this is the length. So if we're here or greater than here, that means this is about to cut off, so we have to do something. All you have to do is add the length to the starting position. So you can do start position.x plus equals sprite size.x. And since we're moving the transform position x by doing start position.x plus the speed, if we add the length to it, it'll properly loop the layer. And this works if we're going to the right. So if the camera is moving to the right. However, if we're going to the left, we need another if statement. So else if the relative camera distance is less than the start position x minus the sprite size x, then you can do start position dot x minus equals sprite size x, which this is just all it's doing is this is moving to the right and this is moving to the left, and this covers both cases. And so basically this simply moves the image forwards when our camera relative to our layer passes a certain threshold, which in our case we put the threshold as the starting position or where it's currently at plus our length. I hope that's making sense so far. So now if we click play here, you'll see that once we reach this point, it'll start looping. However, there seems to be an issue where it's not looping at the correct place. And so after a little playing around, I just realized that for some reason our hills are starting at 18 in the X position, which is messing up the initial position. So let's just set that to 0 and make sure to unparent these other hills. And basically we just want to make sure that the hills start in the center. So the middle hill is on the center of the camera. And then this hill over here, we can just move it to the correct location and just adjust it as necessary. And make sure to set the other two hills as children to the main hill. If you don't put it in the center, it'll mess up the looping. So when we move the main camera, you'll see that when it goes all the way to the right, it will slowly loop, and you can't even notice it in the game because it happens so quickly. And if it's easier for you to see in the camera, you can press the clear flags. Instead of skybox, you can use solid color, and you can select a color so that it's kind of easier to see the hills. But basically you move the camera and the hills follow along in both directions perfectly. Awesome. So now let's add in the other two layers just so you can get a feel for that. So for the sprites, we can add in here the mountain. Once again, we can scale it so that it's roughly the screen size, and then you can scale it accordingly, or you can even make it higher if you wanted to. I also like to set the color of this differently so we can better differentiate against the sprites. Usually in the background you have darker colors, and in the foreground you have lighter colors. So you can just set the colors here as you see fit. So then you can duplicate this, drag this over to the right, press V to snap it to the other side. Press Ctrl D again, move it over to the left, press V, snap it. Then you can make these two a children of the main mountain. And you'll see that for some reason this mountain is on top of the hills. And that's because we haven't told Unity what sorting layer the sprite should be on. So in the mountains, you can add a sorting layer here in the sprite render. You can click this add button. So we're going to have 3 layers. We're going to have a background layer. We're going to have a middle ground layer, and then we're going to have a foreground layer. So for the mountains, you can click one, press shift, select them all. And in the sorting layer, put background. And for the hills, you can select them all. And for the sorting layer, put foreground. And now it'll adjust the sprite rendering accordingly. And lastly, we can just add in the clouds and do the same process. We can add the sorting layer to middle ground so it appears in the middle. You can set the scale as necessary, and you can drag it down here wherever you want it to appear. Then you can Ctrl D, drag one over to the side, Ctrl D, drag the other one over to the other side. Make those two clouds a child of the main cloud. And then for the mountains and the cloud, you can add in the Parallax Effect script by adding the component. And then the mountains, you want it to move slower than the hills. So the hills are currently at a 0.5 parallax speed. So we can try putting the mountains at a 0.1 just to see what happens, and the clouds at a 0.3. And to make it easier, I actually like to add a little placeholder. So I like this moon image. So I'm just going to import the moon image, gonna change it to sprite and apply it. We can just add this moon over to our scene and have it just be a static moon, not moving. You can scale it up so we can just get a better reference point to how our layers are moving in relation to a static object that's not moving. Alrighty, so now when we click play, you'll see that if we move our main camera, all the layers are getting shifted. You'll see that we have this little cut here, which we can always fix later. But the layers are moving accordingly. It's pretty nice. You see the background's not moving as fast as the foreground, so it looks relatively accurate. So that's the main gist of it. So now I just want to show you how to add a simple Y parallax effect, which is the same as in the X, but in the Y. So if your character jumps, then it'll look more realistic, which is pretty easy. If you go back to our script, all you have to do is do the same process for Y, So first we have to take into account our starting Y position. So let's make another variable, start position Y. Then we can duplicate this. In VS Code, you press Shift, Alt, and down on the line that you want to duplicate, change it to Y, and then change the start position X to Y. Then right here, for relative distance, we can just duplicate that line. Instead of X, we can do Y. And for relative distance, we can just do relative distance Y. And I actually recommend this, but let's make another variable for the parallax speed Y and one actually for the X, so that we can have different speeds for the Y and the X. So make sure to change the previous parallax speeds to parallax speed X, change the relative distance Y's parallax speed to parallax speed Y. And then in the transform position here, instead of setting the Y to transform position.Y, you can just do start position.Y plus our relative distance Y. Same process as before, but now you can set in the speeds again. For some reason, it erased it for me. Lovely. So in the parallax speed X for the hills, we can put in maybe 0.8. In the Y, let's keep it low, so 0.3. In the mountains, we can do, which are the background, we can do 0.3 on the X, 0.1 on the Y, and the clouds are the middle. For the X, we can do maybe 0.5, and for the Y, we can do 0.2. You can actually reorder this around so it makes more sense. And you can also rename this to be foreground, middle ground, and background, which I'm pressing F2 to rename it. Alrighty, so if we click play, see that we move our camera moving normally. When we move up, you'll see that the Y's are shifting a little bit, which is cool. Well, it seems they're shifting a little bit in the wrong direction, because if you jump up, you'd expect to see more of the scenery, but for some reason it's going backwards. So we might need to increase these values. So for the mountains, maybe we can put 0.5 just to have a try at it. And you can see that now when we jump, the mountains appear more, which makes sense. The middle ground, we can put in like 0.5, and the hills, we can maybe put a 0.4. And you can just play around with these values until you find some that fit. So that's the main gist of it. If you wanted to write a simple script to have the camera move horizontally over time, I'm not going to go over it, but this is the script. All you have to do is get the current position of the camera, add in the X, the new speed, times time.delta time, which I just set the speed to 3, and then you set the camera position to the new position if you want to have the camera moving on its own. But yeah, it should look something like this. It's a simple parallax script, and it'll help give you more feeling to your game and make it look more polished. So I hope you enjoyed this video and that you found it useful. If you did, make sure to like and subscribe if you have not already. And thank you so much for your support on Patreon. It is really appreciated. Helps me out a lot. If you're interested, my Patreon is in the description. I offer source code, early access, exclusive Discord channel, and more. And with that, I want to thank my new patrons. In the enthusiastic tier, we have Shahar, Sasha, Nicholas, Cameron, David, Jimmy, Jordan, Anthony, Adam, Elena, N7 Starling, Nicholas, Tom, Noella Channel, Lee, David, Skur, Bar, Piyush, Tom, Memer, Alex, Rod, Stephanie, Von Doom, Jesse, Felipe, and Eric B. Thank you so much for all of your support. It is so very much appreciated. It helps me out so much. And once again, if you're interested, the link is in the description. And if you haven't joined our Discord channel already, make sure to do so. Link in description. You can ask questions, post memes, or just chat. So thank you so much for watching, and I'll see you next time.